Okay, here we are.
But no, I've never did that first. And I did it like last week. I sat down and I was like,
Okay, so here are the different topics for test number 4. So the first main topic is two variables. So that means that you will need to be able to graph things. That also includes doing hypothesis tested correlation. And then for regression, that you would interpret the slope. You would also interpret the line, what that means, okay? And then we'll have confidence intervals and prediction intervals. Those will all be things that have two variables. Then we have multiple samples. First of all, for proportions, goodness of fit. And goodness of fit, you will have hypothesis test and confidence intervals. Test of independence, you will have hypothesis test, but no confidence intervals. And then ANOVA, which we just did, hypothesis test and confidence intervals. Okay, this is all on Blackboard. And then we will also, if you go to test for review problems, you see that it refers to different problems from the textbook and various instructions and so on and so forth. Again, this is not an assignment. It's just something that we'll go over in class, but it would be good for you to do it so that you can be ready for test number 4. All right. Test is on Wednesday. That's correct. We're going to go through that set of problems down here on Monday. Okay. So we are looking at a two-variable situation. And what I'm going to do is tell you about a thing. We did talk some about this earlier, but we did not do it in two variables. But what we're going to do is hemoglobin as X and blood pressure as Y. Okay? So, well, we'll just do it. How about that? Here we go. Now, this might look like a cloud to you. Certainly seems like one, first glance. As it turns out, there is a regression line that we can do for this because we have so many points. There's like 500 and some. So, no, sorry, there's 270 some points on here. So what we're going to do is we're going to create the line that's actually going to go through these points. And the equation of the line, this. Okay. So, what I want from you are some numbers that I can use to put on here in order to make this line on this graph. And I want 3 points. Okay. I'm going to let each one of you pick whatever you want to do, and then we're going to collect them all together and see if we can make it happen. Okay. Excuse me, Natasha, what did you say? I'm asking you to give me points that are on that line, and I will put them up on the screen, and we will use it to graph the line.
How do you know what point that is?
That's
Based off of that, how do you use that?
okay. This is what I am testing you on right now. Okay. All right. How many of you know what to do to start? 1, 2, 3, 4. Maybe 5. Okay, that's what we're going to do. 5 people out of here, maybe 6. Okay. There were a couple people that came by my office and sat down and asked me a question. You pick them. Just pick them. What? Pick what?
Any number, as long as.
What numbers?
Any.
What numbers?
Any numbers.
Can I pick 3,000?
You got them. I mean, you could, but it's not right.
I could, but it's not right. Okay, so what numbers do I need to pick? Within the chart. What numbers am I picking?
From the low and from the high.
From the low and from the high of what?
Like, so around 6 and around 18.
So what numbers are those?
5.
What are they measuring? Which ones are you talking about? What coordinate is that? X.
That, okay.
All right. Which X coordinates do you get to pick? Any. But what makes the best sense? The high and the low ones. You can pick any X values, but you should probably pick high and low ones. All right. This is what's going to happen on the test. I'm going to give you something like this. I'm going to say, here's the equation, graph the lines. What X values are you going to use?
Any.
Any. Which one should you use?
High and low.
High and low ones. How do you know which ones to use?
It's on the chart.
If it's on the chart.
Will you put that up and draw a line and show me where you do it?
No, I want you to pick X values. It doesn't matter which ones you pick. I want you to pick a low one and I want you to pick a high one. It doesn't matter which ones you use, but you have to pick.
So like the 5 and the 18, is that what you're saying?
5 would be off the chart, so let's not pick 5.
Or what is that one that's on the chart?
What's this number right here? This is a 6. This is 8.
5.8.
This would be 7. Does it make sense for you to pick something that you don't know what it is? No. You should pick something that you know what it is.
What you want?
Nikki, do they have to be values that have data points? No. You can pick any values.
Oh, yeah.
All right. Do they have to be values that are data points? Do they have to be values where there is actual data?
No.
No, it can be anything. What should you pick?
A high and a low.
A high and a low.
X.
Can you pick any X values you want? As long as you have high ones and low ones. It doesn't matter. Pick any ones you want. How do I know which X values to pick? How do I know which ones to pick?
On the chart.
Can I pick any one?
Any number. Second 10-minute conversation we had on that. I better remember.
I was like, I'm gonna pick 80 one day, and they're gonna be like, what numbers pick on the chart?
Okay. What numbers can you pick? Whatever you want to. Abby, give me a number.
6.
6. That's the X value. What's the Y value?
96.868. So are we rounding to like a whole number?
Yes.
97.
So if X is 6, then Y is approximately 97. Do we have agreement there? Does anybody else pick 6 and got that same number? Doesn't matter. Okay,
That's by putting in 6 into where it says x and solving the equation.
correct.
That
Okay.
comes out to x.
All right. Kelly, you got one?
16 and.
Okay, 16. Did you put it 16 in for x and get the y value? Have you put in 16 for x and found the y value? Did you take the number 16, put it in here, multiply it and add it and get the y value? Okay, I want you to do that right now. Okay. Did you get an answer?
Yes. 120.24.
We're rounding to the whole number.
120.
120. I want 3 values. What else should I use? How would I decide which one to use? Can I use any value? I can use any value. How do I know which one to use? I just pick one. What do I do with it after I pick it? You compute it.
That makes so much sense. I get it now.
Okay, good. There we are. So Jackie, did you do this yet?
Oh, no, I just did those.
Okay, so you just did those 2. Okay. Would you have to do these 2?
No,
No.
no, but it made me understand it.
Okay. Could you pick other values?
Mhm.
Would that be fine?
Mhm.
It would be. Which one should you pick? High and low one. All right. You should not pick 12 and 12.1. Yeah, that's not going to help you. You want to be able to draw a line. Makes sense that you would use values at the bottom, values towards the top, and then something in between. Does it matter which one you pick? No. Okay. Alyssa Peterson, you got one?
Yeah, I did 18. Yeah, sorry.
18.
And then I got 124.924.
Well, that's not going to help us a whole lot because we've already got 16, which is kind of at the high end. I'd like something that would be, you went the highest. So 18, what did you get for that?
124.9.
So we're rounding to the whole number here, 125. That worked. Do you have anything in the middle?
The highest and lowest.
Okay, we want something in the middle.
I did 12.
12. What do you get for 12? Did you get a value for y with 12?
111.
111? Okay, anybody got something else? Everybody pick 12? Right? That work? Six, 97. 12. 111. 16. 120. 18. 5. Right there. There it is. What do we know about this relationship now that we've drawn this line? Or what should we have known at the very beginning? What does this line tell me?
Direction and location.
Okay, tell me about the direction of this line. It's positive. What does that mean, Kelly? Okay, what does that mean in relation to what we're talking about?
As the hemoglobin higher though.
Okay, as the hemoglobin gets higher, the blood pressure gets higher. How do we know it's positive? How do we know it's positive? Okay, what number in my equation tells me this is a positive relationship? Nope.
2.33.
Which is the slope. The slope of this line is positive. Since the slope is positive, then that tells me it's a positive linear relationship. If that had been a negative slope, then I would know it's a negative relationship. So right now I know this is a positive relationship.
Positive linear
Yes.
relationship.
Yes. Okay. Now, we're not going to do correlation on this one. We'll do correlation on a different one. But we're just going to talk regression here. Okay, here's our regression. That's our regression equation. Okay, and this is how we can make that line happen. Okay. But let's do something different for correlation. Let's do the NFL. That's always fun, right? New data table. Data load my data. Oh, well, we did that, I think, before. Let's try this. Okay, so we're going to look at first downs and yards. Did we do that already? I'm not sure if we did that already. But let's try it. First downs, X, yards. Question, simple linear, first downs. Okay. Right now I have a correlation coefficient of 0.8634. I want to do a hypothesis test for correlation. So, Casey, can you tell me what my first step is for hypothesis testing?
State the hypothesis.
Okay, I want to state my hypotheses. Casey, can you tell me what my hypotheses are for correlation? Jackie, you want to tell me what my hypotheses are?
Equal to or?
Oh, is it the row?
It is rho.
Yes,
It is.
okay.
Okay.
So slash and P
Okay.
equals 0,
Yes.
and then slash P doesn't equal 0.
Does not equal 0. That's correct. Hey, how about that? That felt pretty good. Okay. Alicia Bell, can you tell me what the next thing is? Okay. And so we're going to go to table, what's the I? Which is on a page out here, right? 658. Oh, they closed my session. They do that, you know. There we go.
Using alpha 0.05.
We are.
How many data sets do you have?
We have 32 data values.
Oh, how did you just decide that now?
I did.
Oh, okay.
Yep. We have 32 data values, so what's our degrees of freedom? 30. So what's our critical value? 0.349. Okay. So Danielle in the front here, can you tell me what happens next?
You compute the value.
Okay. What happens here then?
You just compare. I'm not sure.
Okay. Kelly, can you tell me what happens next?
Draw a little graph.
We draw a little graph. Yes, we do. What do we have on our little graph? Oh, I'm sorry, question?
How did you get the critical value?
We looked on table I believe it is, which is not on your, it's in the book, it's not in the,
Oh,
not on there. Okay. So what's our chart look like here, Kelly?
-1, 0, and +1.
-1, 0, and 1.
So you put 0.349, right, and then 0.349 on the left.
Okay, we put 0.349 on the right, negative 0.349 on the left, and we shade out from there. Okay. So, Ali, what does that mean then?
I'm sorry, what? I was grabbed.
That's okay. Tell me what to do next.
Find the test value.
Okay, and in correlation problems, what do we use for the test vector? Okay, it's in there somewhere. Nikki, what do we use?
Is it the correlation coefficient?
It's the correlation coefficient. Yes, it is. So what's that number here? 0.8634, yes. So that's the test value.
How wide?
Okay,
Never mind.
there it is.
Oh, okay.
There it is.
Never mind.
All right. So we have it. All right. So, Ali, what do we conclude? Okay. In the rejection region, so we do reject the null hypothesis. So, Brianna, what does that mean?
It means that there is enough evidence to prove the alternative hypothesis, which is growth is not.
Okay. What does that mean?
There is a linear relationship.
There is a linear relationship, yes.
How many points off if you forget the last part?
If you forget to use the word is, that's a lot of points off. If you say is not, then that would be bad.
No.
Okay.
There is a linear relationship. I'm not gonna remember that.
Yeah, you better. You really should.
That's the correlation.
Okay, but we're not done because we don't.
Add that to the
Yeah.
conclusion.
So now we need to actually know, what does this actually mean? Okay. So Brianna, can you tell me what this actually is?
Sure, I got someone.
Okay. Abby, can you tell me what this actually means? Nope. Donna, can you tell me what this actually means?
There's enough relationships to reject it?
No, I'm talking about the actual problem.
Oh, sure, I'm sorry.
That's all
Go
right.
back to the football and X's and Y's and yards.
Okay, that's correct. So how do we express our conclusion then?
That whenever you get more yards, you get more points, or what was the two?
Oh,
First down.
I don't know. I was like,
Okay, all right.
If you get more first downs, you get more yards.
You get more first downs, you get more yards, and that would be the expression of the positive nature of it.
Yeah.
But that's not really what we are saying here. Okay? What we are saying here is that there is a linear relationship between first downs and yards. Okay?
what did it say about your hand?
There is a linear relationship. Okay? So when we do correlation, all right, we're trying to answer the question, is there a linear relationship? The answer is yes, but in our answer we would say, yes, there is a linear relationship between first downs and yards. Okay? And again, if you get most of that, you're going to get most of the credit. But in order to get full credit, you would actually say there's a linear relationship between first downs and yards. Okay. All right, that was correlation. We talked about regression, and now we need confidence intervals and prediction intervals. Are there any questions about this that need to be addressed? Sure, yeah, let's do one. Yeah, let's do one right now.
When there's not a word problem.
Okay, yep, we can do that. Okay, so we'll go to chapter 10. Relation.
Answers for those question problems,
Yes.
are they from the book that they have had?
Yeah, I think so. How about that? It's for review problems. Is there at the end of the chapter, I think.
Oh, there are pages and numbers.
Yeah, so I'm pretty sure those answers are in the back, yes.
Okay.
But it should be the even numbers as well, shouldn't it? Well, the problem is that I have the instructor version, so it has both. So if I go here to the ebook, or do I have the ebook? Yes, I have the ebook. All right. Tables. Oh, selected answers. That's what we want. Okay, so we're looking at chapter 10. Yeah, all the answers are there for the end of the chapter question. No, sorry, wrong. The chapter quiz. Yeah, I can just email it. All right. I can make that work. I can put them up on Blackboard then too. All right, so answers, practice tests. That's a good idea. All right. Okay. Any other questions about correlation?
Yeah, the word.
Okay, the word problem. Yes, that's right. I knew there was a reason why. So let's look at okay. I'm gonna find this any minute now.
Well, the correlation coefficient thing is a given, right?
Just like 18.
That's given in the problem.
Yes. All right, book contents. Here we go. Chapter 11. And then we go back to the end of chapter 10. There we go. Okay, so here is deaths from lightning. I'll give you a minute, let you read it. Okay, Ally, so far?
Yeah.
Okay, so then what that means is we would do this hypothesis test on correlation. And then we would come to the end and we would say, yes, there is a linear relationship between deaths under a tree or other types. Or we would say there is not evidence to prove that there's a relationship. Okay? There you go.
Thank you.
All right, so now we're going to talk about confidence intervals and prediction intervals. We're going to go back to our hemoglobin situation. It looks like this. Okay, but specifically, I'm going to be giving you numbers, not a graph. Question.
If we're looking for like A and B, kind of going back to the formula, sorry guys.
That's right.
A is the one with the X, right? And B is by itself, and I just flipped.
You just flip. Okay. But B in algebra is the same as A in statistics. Okay. So if I were to write this, this is the statistics way to write it. If I were writing it in algebra, it would look like this.
Where do you get those numbers?
This comes from the computer. I click a button and say, here it is.
I get it.
Okay? This is the slope that's in front of the X.
So on the test, you said that you're gonna give us those numbers.
Yes.
Are you gonna give it in the statistics form or the algebra?
Not sure.
I
How
thought
do we know?
statistics because it's just statistics.
I think we should just keep it one and the other so we know.
But when you go out there and actually look at things, it could be either way. So what you have to do is recognize that what's in front of the X is the slope, whether it's written this way or this way. You need to be able to recognize that the slope is in front of the X, no matter which way it's written.
Yeah, that's the last test we should do.
And then the other number is the intercept. So we have this. This is the line. This is the two ways it could be written. And we have, if X is equal to 12, Y prime is equal to 111. Okay, we know that. Okay, but now we're going to know a little bit more. And that is we're going to know confidence interval and prediction interval. So for the confidence interval, we're going to have 106 and 116. Then for the prediction interval, we have 44 and 177. Okay, so again, I'm giving you these numbers. These are the numbers that the computer is telling me are the confidence interval and prediction interval when I have x is equal to 12. So I have these numbers right here. So then my question is, what do I conclude about, or how do I describe? I should say, I should not use the word conclude. How do I describe a data value where x is equal to 12 and y is equal to 82? And once again, it's possible for you to describe some things about this, but I would prefer that you describe it in terms of the actual measurements that are being made. Okay. So the first thing that we need to consider is the confidence interval. What is the purpose of the confidence interval? Okay, it's going to measure something about a population. What are we measuring in this situation? This is the hemoglobin thing again. Oh, so I better change my things here. Hemoglobin is X, blood pressure is Y. How do I describe a data value where X equals 12 and Y equals 82, given my confidence interval goes from 106 to 160? Well, that depends on what a confidence interval tells me. Confidence interval tells me something about a population. What are we actually describing here? What is it that we are measuring? We are measuring an average. Average what? Average for Y values. What does Y measure? Blood pressure. So we're talking about average blood pressure.
How do you know that's what you're talking about?
How do we know that's what we're talking about?
That's what is the Y.
The Y value is what's being predicted here. And confidence intervals talk about a measurement of a population. And in this particular case, when we're doing regression, we're saying it is the average of the Y value. So when we're talking about regression, this confidence interval is the average Y value. And so this would be the average blood pressure for somebody with 12 hemoglobin. So what we're looking at here is a confidence interval that says the average blood pressure for a 12 hemoglobin is between 106 and 116. That's what the confidence interval tells me. So how do I describe that specific data value? It's lower than average. So from the confidence interval, this is below average. What do confidence intervals describe? Something about a population. What are we looking at here? Average Y value. So the average blood pressure for someone with 12 is between those two numbers. This particular person is below that confidence interval. So they are below the expected average for blood pressure. Okay, that's the confidence interval. What about the prediction interval? The prediction interval is not telling me about an average. It is talking about the data values. So these are data values of Y for specific. So now what happens? From the prediction interval, what do I say about this person? Are they outside of my prediction or are they inside of my prediction? Where's my prediction interval? From 44 to 177. Is this 82 inside that interval? Yes, it is. 82 is inside this interval.
We're not looking at, yeah.
So if it's within the prediction interval, what do we say about it? Nope, not average. It's within the predicted one, so the best way to say it would be it's not unusual. Okay? From the prediction interval. This is not unusual. So let's take a look at this person. They are right there. Now they just turned pink. What do I know about this person right here? They're lower than average because my average is in here. They're below average. But they are not unusual because this is where my data prediction is. So anywhere from here to there would be predicted, and they're fine as far as being predicted. This person here is unusually low. You would be surprised that they have this low blood pressure. This person is unusually high, so that's how it goes. Now, when you look at this, would you consider this to be mainly a cloud as opposed to a straight line? Yeah, it looks very cloudy. How much difference does hemoglobin make in a person's blood pressure? Not a whole lot, okay? When you say, here's the average, which is about 100 over here. Here's the average, which is about 102, like that, right? Now, this would be 111, right? Rosalie? Well, So it makes some difference in terms of average, but it doesn't really help you to predict. If somebody walks into the clinic and you measure their hemoglobin at 12, you can't really know what their blood pressure is. It's somewhere between 44 and 177. That's a huge difference, right? So this is not going to really help you to predict what's happening to somebody's blood pressure. You might be able to pick out some people that are way low or way high, but this is not really going to help you to know what's happening. And if we look at our regression, which I said we did not have to, but we're going to just look at it here. The R squared is about 3%. So hemoglobin is about 3% of the explanation for your blood pressure, which means that, it doesn't really make a difference, much at all. Okay? It works, but it's not very effective as far as predicting things. All right. So we're going to stop here since we've been going for quite some time. And then next time we get together, you'll have the benefit of those problems to look at, and we'll go through those specifically. And then we will be done, and then we'll have a test a week from today. Yes, yes. I'm certainly thankful that we can be done.